Brenton Young from AOSense. Thanks so much for the opportunity to describe AOSense capabilities in quantum sensing, atomic clocks, and down here, thanks. Atomic clocks and enabling technologies. Quantum sensing and clocks are really poised to dramatically improve capabilities in defense, national security, and commercial applications. AOSense has a broad range of different applications that it targets. However, our prime mission has been to develop or improve navigation timekeeping for GPS-denied environments. As far as navigation is concerned, the ultimate performance that we anticipate for atoms would be to achieve navigation and accuracies less than 5 meters after about 24-hour of navigation time. Typical aircraft navigator drifts about half a nautical mile after an hour. So this represents about a 200 times reduction of the error for a longer time period. In terms of atomic clocks, right now they're the best clocks in the world perform much better than the nanosecond per year that we're quoting right here, but those are inappropriate for fielded missions. And so AOSense's objective is to be able to deliver atomic clocks that will perform at this level on moving platforms. Actually, back up here. If you look at classical sensing technologies, like the best conventional accelerometers and gyroscopes, they're vastly different technologies. One of the strengths and appealing features of quantum sensing is their commonality. Because of that commonality, a small company with a modest staff about 35 at AOSense has really been able to achieve significant advances and demonstrations in a broad range of different sensing modalities, as indicated there. The green checks indicate that we've developed a laboratory prototype and demonstrated it, and the gold stars indicate that we've demonstrated it either in a field or an external testing laboratory. When AOSense first started in 2004 developing quantum sensing, there was very little in the way of enabling technology suitable for fielded systems there, which really motivated AOSense to develop some of our own, leading then to the next slide, which shows some photographs of some AOSense enabling technologies in photonics and vacuum and electronics. For example, our laser diodes and our laser driver electronics deliver ultra high performance at low size, weight, and power or swap. And premier research groups around the world purchase our high brightness atom beam systems to accelerate their quantum research, enabling them really to focus on the physics rather than focus on engineering atom sources. The quantum gyros will soon be revolutionizing GPS-denied navigation. In 2021, the DARPA approved public release of AOSense results from 2009 on quantum gyros that really achieved outstanding noise and bias performance. You need to wait for about 1 hour for this gyroscope to drift off by 1/1,000,000th of 1 degree, which is really extraordinary stability. Subsequent research at AOSense has been focusing on taking that type of technology and being able to transition it to operate under motional dynamics, and also to be able to combine, single axis sensors together into what you'd describe as being a 6-degree of freedom quantum inertial measurement unit, or QEMU. Recent advances in this area in 2023, Boeing announced a collaboration with AOSense in which we demonstrated the world's first 6-degree of freedom quantum IMU on a ground vehicle. So that's some information on that depicted there. In the lower left. And then this year, we continued on and we demonstrated the world's first quantum IMU on an air platform. So again, that's 6-degree of freedom, 3-axis accelerometer, 3-axis gyro, all of them quantum. Given sufficient funding, our goal is that around the year 2030 that we will be able to field an engineering prototype for a quantum IMU that will reduce the current volume from about 100 liters down to about 6 liters. The current version that we're doing the testing on is basically taking 3 separate single-axis sensors, combine them all together, and so then this will be something engineered for the for an integrated system. So in terms of absolute gravimeters and gravity gradiometers are very useful for national security, for precision navigation, and for geophysical exploration. Very useful tools. And so this table here, and AOSense delivered in 2010, about 14 years ago, the world's very first portable quantum atomic gravimeters, this single axis device. And this table summarizes and compares existing technologies for absolute gravimetry against AOSense target of what we want to put into production around the year 2025. And what it shows is that our goal will be to deliver much better sensitivity in a drastically smaller package. The key thing to compare there is the 1,500 liters, 480 liters, and 20 liters. And so what's depicted there in the lower left is a less than 20-liter container that includes the entire system, whereas the conventional systems all have kind of a separate electronics unit and the sensor head. In this case, all the hardware is integrated into that one unit. If you have an interest in assessing the capability of quantum sensors or advanced clocks to improve your applications, or if you have an interest in accelerating research using components, please contact us. Thanks.